Welcome back to the law of sine and cosine. We're now going to look at the ambiguous case, where you could have no triangles, one triangle, or two triangles. And so the possibilities are given here below. I just want to point out that our angles in this diagram are Greek letters alpha, beta, and gamma, and the sides corresponding are side A, side B for beta, and C for gamma. Although C isn't given here because gamma could change, so it's basically a dotted line. And this gamma angle, as it changes, so will this side A. If we know this side A, but it swings across because the gamma angle can change, and it doesn't touch anything, that means there is no triangle. So when the side A is given, and it's too short, it's shorter than if it was a right triangle, and it doesn't touch, eek, there's no triangle. This is when the side A is less than h, the height of a right triangle. Now let's look at the next case. Let's say again we have angles alpha, beta, gamma. And it's a good idea that you become comfortable with these Greek letters. I know it seems a little silly right now, but it's definitely going to help you now and in calculus. So you have these angles, and then respective sides, A, B, and C. If it's a right triangle, that means that side A is equal to the height of a right triangle, and you will get one right triangle. The next case is probably the most challenging one to wrap your mind around the first time you see it. In this case, we have a rotation of the angle gamma, and as you can see, the side A is greater than the height of a triangle. So the height of a triangle would be this right triangle here. And if A is just a little bit bigger than H, but A is smaller than side B, that means A is between the height, which is the small one, and B, the side, given. If A is in between them, we can think of the leg A as swinging through, hinged on the angle gamma. And as the angle gamma changes, it will bump here, kind of like, think of it kind of like a magnet. It bumps here, and then it swings through, and then it sticks here as well. It bumps this side C opposite the angle gamma. What that shows me is that the oblique triangle given here with a small gamma angle, but I could also have a different one, which is kind of cool and kind of weird at the same time. So first, let's pretend we have this angle swinging through and bumping side C. That means the angle on this obtuse beta will have changed, because before beta was an acute angle. And then we're going to also compare it with what the original was. The original triangle looked like this, where it continued off, and this was when gamma was large. The angle gamma was large. So you can see how if A is between those two values, the height of a right triangle, and B, the other side, you could get two different triangles. And then lastly, you could also get A greater than or equal to B, in which case A doesn't swing through, because if it swung through, it would do something like this, and that wouldn't make sense. It would just collapse on itself. And so it just sits there exactly how it is, and it's convenient. So once again, you have one right triangle. In this example, we're asked to solve the triangle ABC for A equal to 42 degrees, side A equal to 70, and side C equal to 122. I'll go ahead and sketch my triangle first, knowing that side A is 70 and angle A is 42. So I have done I've attempted to draw the triangle the way I think it's going to look, but I'm not positive because I don't know the angle B or C. But I do know that if I were to try and draw a right triangle here, it looks like it would be something like this. My side A might be between the height and side C. We shall see. I'm not sure. Since angle B is not given and side B is not given, I need to dot this side as well, because I don't know yet if that's going to work. We might have an ambiguous case on our hands. So let's try and find the height h. We can find that by taking opposite over hypotenuse. That will be sine of 42 degrees equals h over 122. And I can find sine of 42 degrees times 122 on both sides to clear the fraction. So h is equal to 122 times the sine of 42 degrees. Put your calculator in degrees. Multiply 122 times sine of 42. That means the height is 81.633. We'll just round it to full numbers, so 82. If the height is 82 and A is 70, that means I have not drawn this to scale at all. That's saying that my side A is super short. It's like this length here, where H is 82 units long. And since H is greater than A, we have no triangle.